Hello, we continue with chapter 0 of M2, okay? Now, this part is about function. Functions are very important in mathematics, and this part will talk about some special functions, special properties of function, or some other operations of function. Now, first, you have to know this term, composite function. Now, function simply can be regarded as relations between two variables, at least two variables, and of course there's one more condition that whenever I say input one unknown or one value, then I will just get one unit value only. Okay, but basically, if you look at the usually you will encounter functions written just like an equation, okay, connecting two variables. Now, for composite function, I will take this one as an example. Now, if you look at this one, okay, there's a function called f, okay, f the independent variable of this function f is u, okay, it's and this part gives you the idea or the instruction how we operate on u, okay. We will take the square of u and then plus 5, and therefore it means, for example, you start with something called u, and then after this function f, okay, it becomes u squared plus 5, okay. If we take particular value to be the input, for example, if u is 1, okay, after f, okay, it becomes 1 square plus 5, okay, which is x, that's 6, alright. And then this is the result, okay, and I can call this one, okay, I give the name, okay, for the result, and this result is also a variable because it depends on this independent variable, okay. For this function f, okay, this part is called dependent variable that you should have encountered this term before. Now, in this case, if I call this one x, okay, now then x is a variable, okay, therefore it can be also treated as an independent variable for another function, just like in this example, the second one, g, okay. It means g takes up the independent variable x, and then how we manipulate x, we have x plus 3 over 5, and therefore here it means for this x, okay, it is the independent variable of g, okay. Afterwards, if I input x, I should have x plus 3 over 5. Now, if you focus on these two, think carefully. Is there any relations between u and this result x plus 3 over 5? Now, you can look at it. We can start from the beginning. It means we start from u, okay, and then after function f, I will get a result u squared plus 5, and then I take this one, okay, this result to be put into g, okay, and then I will get another result. Therefore, basically, there should be a relations between this u and the end product x plus 3 over 5. Of course, in this case, it seems that the relation is not clear, but if we just look at it once again, what is x actually here? What is this x? X is got by u squared plus 5. Therefore, I can rewrite this one as, we place this x here. This x is actually comes from u, okay, u squared plus 5, okay, this is our x. and then plus 3 over 5. Okay, therefore in this case we can further simplify u square plus 8, okay, over 5. Okay, and then it means it's just like we actually start from u, and at the end I get this result. But for this one, the process involves 2 steps, okay, involves 2 functions in this case, and therefore this part we call it a composite function, and then for our notation we'll write in this way. Oh, sorry. If in this case, in this way, or if you further look at the notation, you can look like that. Start from the beginning. We have the variable u, and then this u, okay, is processed by function f, and then we get the result here, and then this result will be processed by some other function g, okay, like that, okay, and then this one is called the composite function. Okay, alright, let's try this example. Now suppose fu equals 1 minus u times 1 plus u, okay, this just gives you the definition for this function, okay, and then there's another function called gx, okay, equals cosine x, and then find f of gx, okay, this is the composite function, okay, of f and g. Now therefore in this case, we start from here. First we have x, and then after g, okay, after the function g, what we get, it is cosine x, and therefore this gx is replaced by cosine x, like that, okay, and then this one will be our independent variable for function f. Okay, how we add on u, or how we add on this variable. If u is the independent variable, we have 1 minus this variable, okay, the result, times the sum of 1 and this variable, and therefore this becomes the u here for this function f. Therefore, according to the definition, we have 1 minus cosine x, and then times 1 plus cosine x. And then we have already got the definitions for the composite function fg, okay? But of course, you can look at this, see whether you can further simplify to rewrite it in a better way, okay? This one, if we expand the bracket, we have 1 minus cosine square x, and then it actually is sine square x, okay? Therefore, it means f of gx is actually sine square x, okay? Right, and then you can try the try the problems written in your worksheet. Okay. Now, other than composite functions, we have something called inverse function. Now, inverse function has the idea just like we have a reverse process. Okay. Now, in this case, we have, if I take this one as an example, okay, okay, under function f, we have u squared plus 5. Okay, if we can reverse the process, okay, and then this part is called the inverse function. Okay, it means this part becomes the independent variable. Okay, and then we just like going backwards. Okay, to this one. Now, whether it is an inverse function, it also has to fulfill the condition for function. Okay, of course, the first condition is usually fulfilled. Okay, there must be a relations between these two variables. But there's the case that we must ensure that if say if I call this part y, okay, if I input any value from this one and then under this operation, I can just get one value here. Okay, only one result. Then in this case, this part is the we call it inverse function. You may wonder, will there be any example that no inverse can be found? Okay, now I'm going to give you an example. Okay, if I consider this function, okay, and then it means there's a variable x, and then under this function f, the result is x squared. Okay, let us have a particular value for this example. Okay, if this is 3, okay, after this function f, then this one should be 9, right? Now, if I want to reverse it, okay, it means I'm now going backwards. If I have a value, okay, 9, it means I'm asking what numbers, okay, after squaring, okay, the values is 9, okay, you are going backwards, okay, you are going backwards, okay, you are given the value 9, okay, you think about, okay, what is or what are, okay, the numbers, okay, after squaring, okay, the result is 9, and then you will see that you should be able to get 2 results instead of 1, okay, 3 and minus 3, right? 3 squared is 9, minus 3 squared, okay, the square of minus 3 is also 9, okay. Therefore, in this case, if I go backwards like that, I am given one value, but at the end, I will get 2 results. Therefore, in this case, for this direction, it is not a function. We can just say that there should be a relation between all these values, okay, 3 minus 3 and 9, okay, there is a relation between them. But if you are given 9 and then at the end you have 3 and minus 3, it means you input one value but at the end you get 2. Then in this case, this is not a function, okay, be very careful. But if it is not that complicated, usually we can find the inverse functions just like by just like the problems for changing the subject. Okay, now if I look at this one, okay, y equals log, okay, x, okay, with base 5. Therefore, in this case, it means if I look at this one, it means I have x, and then I take this function, okay, and then at the end I got a value, this one, and then this is y, and therefore we are going backwards. You are given y and then you want to get x, and then if you rewrite the relations of these two variables, okay, it means this time I want to know how to find x, okay, x is 5 to the power y. Okay, and then you just further think about it. For this kind of operations, will there be more than one result? Okay, if means you think about, okay, 5 to the power 1 equals what? Okay, will there be two possible values? Okay, if I have, say, 5 square, will there be two possible values? Okay, for this one, okay, you have learned this before, there will be only one result at the end. Therefore, 5 to the power y is a function, okay? Therefore, in this case, it means x can be found by this exponential function, okay, 5 to the power y, okay? And therefore, this case, we'll call this one the inverse function, okay, the inverse function of this one, okay? And then we look at part B, okay? It's more or less the same. I want to first we try our best to rewrite this equation first for having x be the subject, okay? And then x cubed is y minus 1. And then if I want to find x, okay, we have to take the cube root. Okay, sorry, that should be here, like that, okay? Cube root of y minus 1. And then you further check, okay, the cube root, okay? If you input a value of y, okay, for example, if I have y equals 1, then in this case it means I have cube root of 0, okay? How many results do you get? Okay, in this case we have 0, okay? And then you can further verify by putting other values for y. If y equals 2, okay, then in this case I have 2 minus 1, okay, and then taking the cube root, which is cube root of 1, okay, there is only one value, okay. You can verify by some other values. Of course, this part is not a formal proof, okay, but if you want to have a more formal one, you can try to say sketch or plot the graph of the cube root of y minus 1. Then in that case, you can check that if you input one value for y, you will get one value for x, and therefore in this case this is function, and therefore we will accept this this one as our inverse function. Okay, right, let's stop here, and then you continue with the questions in your worksheet, and we'll move on to the next part later.